Hi guys! So today we're going to be looking at Chapter 10, Section 1, Sample Spaces and Probability. We're going to start off first with finding a sample space. And before we do that, we need to learn a little bit of vocabulary. So let's look at what a probability experiment is. A probability experiment is a trial with varying results. So for example, a probability experiment could possibly be me rolling a six-sided die. For a six-sided die, it's just a dice and it looks like this. You have like one side that has like a 1, and then you have 2, and then you have 1, 2, and 3, and so on. And there's like 6 sides to it. Okay, so let's say that I was to roll that six-sided die. The results of this experiment would be called the outcomes, where if I were to roll that six-sided die, I could possibly receive a 1, I could receive a 2, 3, 4, 5, or 6. And so in total, we would have 6 outcomes, 6 possible outcomes that could happen. I could possibly receive any of these possible answers. And so what we want to do is we want to find a sample space where rather than just looking at one type of outcome, let's see if we have like 2 different events that are happening. You flip a coin, and on top of that, we're rolling a 6-sided die. We want to figure out how many outcomes are there in the sample space. And then afterwards, we'll list out those possible outcomes. So let's start off first with a coin. And I'll write it down. So we have a coin here. I know for a coin, we either have heads or tails, right? That's the only options that are given. You either get heads or you get a tail. Oops, that's not how you spell tail. And so in this possible situation, when you drop it, there are only 2 outcomes that could possibly happen. Either you drop it and you receive a heads, or you drop it and you receive a tail. Now let's separate that from our second situation, which is going to be rolling a 6-sided die. And when I separate it, I am always going to be multiplying, because they're 2 separate type of situations that are happening here. The second one that is happening is that we have a 6-sided die. That's also dropping afterwards. So 6-sided die. In a 6-sided die, again, we already talked about it. We said that there are 6 different outcomes. We could either drop and get a 1, we could drop to get a 2, drop to get a 3, drop to get a 4, drop to get a 5, and the last one is dropping to get a 6. So in this case, we do have 6 different outcomes that could possibly happen. So in total, all I'm going to do is take both the outcomes of the heads and tails, or from that coin, and the 6-sided die, and multiply them together. When I do that, I get 2 times 6, which equals to 12. So in total, after flipping a coin and rolling a 6-sided die, I have possibly 12 different outcomes that could occur. Okay, so last part. After we found out the number of outcomes, we still have to list the possible number, or like what are all the possible type of outcomes that could happen. And in these type of cases, I do like to create this type of tree. So let's start off with the first part, which was the coin. We have the heads and tails. So I'll write down that the first option was that we could get heads. And in that there are possible situation where we do get heads, there is also the 6-sided die, where I could get either heads, and then on top of that, my 6-sided die could roll a 1. I could get a head and then end up getting a 6-sided die that rolls a 2. I can get a head and it rolls a 3, head, and then rolls a 4, and so on. The other option is that, let's say instead of a head, I got a tail. Right? And so in a tail, again, I have those 6 different options. I get a tail, and then when I roll the 6-sided die, I end up with a 1, tail, then 2, tail, then 3, tail, then 4, and so on. And so what I want to do is list out all those options. So the first one was the heads, and we rolled a 1. Second one was that we got a head, rolled a 2, head, and then rolled a 3, head, roll a 4, head, and roll a 5, head, and roll a 6. The other option was that we rolled a tail, so we got a tail and rolled a 1, tail, rolled a 2, tail, rolled a 3, tail, rolled a 4, tail, rolled a 5, and the other one was tail, rolled a 6. Okay, so this would be all of my options listed out. All those possible outcomes that could have happened are shown here. And you're going to notice that, again, we should have had a total of 12 options or outcomes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So as you can see, we did receive those 12 different outcomes. Okay. Let's try it one more time. Let's say that you are asked to flip 2 coins. How many possible outcomes are in the sample space? So again, we have a coin. 1 coin first, that starts it off. And for that 1 coin, you can either receive a tail or you can receive a head. So for that 1 coin, we have 2 different outcomes that could occur. And then, because it's saying that we have 2 coins, not just 1, but 2, I'm going to separate it, again, using the multiplication. And I'm going to flip my second coin. When I flip my second coin, again, I still have those 2 different options, tails and heads. So again, that would be 2 separate options. So in total, if I were to multiply it out, we get 2 times 2, that equals 2, 4. So in this case, we do have 4 different outcomes that could have occurred. After that, again, we have to list out the possible outcomes. So let's start off with the first coin. The first coin, we were either receiving a tail, tail, or a head. Either one, tail or head. And then, after that, after we get that tail, there were 2 other options that we could have received because, again, we flipped 1 coin and now we're going to flip our second coin. So that could also give us a heads or it could give us a tail. Same thing for over here for this head. It could either receive a head or it could have received a tail. So based off of that, I could see that we could have gotten tail then head, or we could have received tail and tail, or we could have received head and head, or we could have received head and tail. And again, we should have gotten 4 different outcomes. 1, 2, 3, 4. Yep, just like how we had found out in the beginning. We did receive those 4 different outcomes. Okay, so now we're going to look at theoretical probabilities. Theoretical probability, which we could rewrite in the symbol of P of A. Okay. It's always the number of favorable outcomes over, so it's dividing with the total number of outcomes. So far, we've learned how to find out the total number of outcomes, but we do need to look at specifically, let's say, for example, in this case, we wanted to say what is the probability of students guessing exactly 2 correct answers. So that would be considered our number of favorable outcomes. That's the specific thing that we want to be looking at. The total number of outcomes is always usually in the beginning. It says here, a student taking a quiz randomly guesses the answers to 4 true or false questions. So we're looking at the outcome of 4 questions, and all 4 of those questions are either true or false. Okay, so let's try it out. I'm going to take my formula, because that's what I'm going to be using to find out my answer here, and I am going to write it down here, just so that we have it. Okay, so again, we said that students, Students taking a quiz randomly guesses the answers to 4 true or false questions. So that would be our outcomes. We want to figure out what our outcome is there. So let's start with that first. If we have 4 true false questions, let's start off with the first question. In the first question, there were 2 different outcomes that could occur from that one question. Either receive the correct answer, which would be true, or it could be a false answer, right? It's either true or it's false, one or the other. And so in this case, you only receive 2 different outcomes. You either get it correct or you don't get it correct. The other one was number 2. It was another true or false question. So again, it was either true or is either false. So you only had 2 options yet again, which is 2 different outcomes. And then for the third question, again, it was either true or it was false. So there's only 2 options only in this case. And the last one was the fourth question, where we had either true or we had a false answer. And so again, only 2 options provided. And so from these different events, we have 4 of them. I am going to be multiplying them all together and then trying to figure out how many outcomes we have in total. So if I were to multiply them all together, 2 times 2 times 2 times 2, that just equals to 16. So in total, I would have 16 different outcomes. And I'll write that here. So down here on the bottom, no matter what, I am going to receive 16 different outcomes. Okay. All right. Now comes the part that they're asking for, which is asking what is the probability of the students guessing exactly 2 correct answers. And so that would be the top part of our fraction, is specifically looking at those 2 correct answers, and it has to be exactly those 2 correct answers. So you can only receive 2 answers being correct in this type of situation. So I'll write exactly 2 correct answers. Okay. So in this case, the easiest thing to do is to just try and list it out on your own. So if we were to look at exactly 2 correct answers, and I'll write that here, exactly 2 correct answers. This will be more like thinking about it conceptually. We have 4 different problems given to us. Let's say that the first 2 we get is correct, and the second 2 we got was incorrect, right? So it was false. We could say that the first answer we got was incorrect, but then we got the problem number 2 and problem number 3 correct, and we got problem number 4 incorrect. And so I want to keep on doing that and thinking about the different options that could have possibly happened on the test. Number 1 and number 2 I got incorrect, but number 3 and number 4 I got correct. There's also a type where you could have maybe the first one being correct, second being false, third being incorrect, and the fourth one being correct. The other one could be that you got the first one correct, but the second one false. The third one you got correct, and the other one you got incorrect. And the last type, I believe, would be getting the first one incorrect, the second one correct, third one incorrect, and the last one correct. And so those would be all the possible outcomes of exactly 2 answers being correct from that test. Okay. And so based off of that, I get 1, 2, 3, 4, 5, 6 different outcomes. So there will be 6 different outcomes from this situation. So based off of that, I'm going to create my fraction now. So here we have our fraction. On the top, I'm going to write down all the different outcomes for having exactly 2 answers being correct from the test, which we found out to be was 6. All the possible outcomes that we could have received was 16. And so that would be my fraction. Last thing to do would just be to simplify it. So I would divide both by 2, and we get 3/8 as our simplified answer. You could leave it as a fraction, so you have 3/8 as your probability, or you could just leave it as a percentage, 37.5%. So that would be the probability of guessing exactly 2 correct answers. That would be it. Okay. Okay, so let's look at probability of complement of an event. Now, I only like to use this formula whenever, let's say like we're looking at a probability where this part of our problem, where it's asking us to find out like the number of favorable outcomes, listing it out would be just too long. Okay, let's say that like this list right here just went on forever and ever and ever and ever, and it was like 100 that you had to list out. Sometimes in that case, finding the complement is a lot easier to do. And to find the complement, you pretty much find out what the opposite of your statement is asking you for, and you're going to be subtracting 1 minus whatever that outcome was. And you'll get the opposite, or you'll find out your answer by looking for the opposite outcome. So what I mean by that is, like, let's say for example we have here 2 6-sided dice that are being rolled. In that case, you do have 36 outcomes, and we want to find the probability of each event. So let's say for example we're trying to find the sum that is not 6. So I have 2 dice, and when I roll a dice, it's not going to equal to 6. Okay, if I do that where I try to list out all those numbers, that might take a long time. And so let's look at the opposite. So the opposite of this statement would be to find out the sum when it is 6. So if you take 2 die and you add them up together, how many times will you get the outcome where adding them up gives you the number 6? So let's try it out. Let's say the first die you roll is a 1, and the second die you roll, again, it has to equal to 6, so it would have to be 5. That works because, again, for dies, we're only going all the way up to 6. So that works. For 2, like let's say you rolled a 2 for the second time, then you would have to roll a 4 for it to equal a 6. The third one, let's say you roll a 3, again, it would have to be 3 for it to roll the outcome of 6. Let's say you roll a 4, that means that you would have to roll a 2 on the second die so that you get 6. And then the last one would be if you roll a 5 and then you roll a 1 on the next one, you get a 6. Again, I can't, like if I rolled a 6, there's nothing I could do because, again, in this case, you have to at least roll a 1, 2, 3, 4, 5, 6. So that's not possible. So I will delete that one. So in total, we received, let's see, 1, 2, 3, 4, 5 different outcomes. 5 possible outcomes for both dies to roll a sum of 6. But again, remember, this is not what we were looking for. Our original statement was doing the opposite. The sum is not 6, so we wanted to find the probability of it not being 6. So to finally answer our problem, I need to use this formula where I'm going to use 1 minus our statement that we found, our outcome that we found right now. So all I'm going to do is write down that we have 1 minus this probability or our outcome that we found over here, which was 5 over 36. So over here, I'm going to write down the opposite, which was 5 over 36, and we're going to subtract 1 minus the 5 minus 36. So if I do that, this is going to become 1 over 1. We get 36 over 36 minus 5 over 36. And that equals to 31 over 36, which you could say is also 0.861 as your probability. And that would be your final answer. Both of them could be your statements that you would receive. So those would be the two answers that you could get from this problem. Okay, cool. I'll move it to the side because I don't have enough space. So I will put the answer right over here. Like that. Cool. Okay, so the next one is asking the sum is less than or equal to 9. So again, finding out the sum of those two dice being less than or equal to 9. So it'd be 9, it could be 8, it could be 7, it could be 6, it could be 5, it could be 4. That would take a long time. I would say that rather than finding the sum that's less than or equal to 6 would be 9, 8, 7, 6, 5, 4, 3, 2, 2, and 1. It might be easier to actually go the opposite route, which is seeing the sum of numbers that are greater than 9, because there's only a very limited amount for dice, because again, for dice, you can only, the highest you could go is to 6 and to 6. So the other possible outcomes you could get here are just 10, 11, and 12. That's it. That's all the ones that we have to look for rather than all of these numbers. So let's do the opposite instead. Okay, opposite is the sum is more than 9, because that would be easier to list out. So more than 9. The die that would be more than 9, I can't use 1 because 1 would have to go to 6. That's not more than 9. That would still be 7. 2 doesn't work because 2 and 6 gives me 8. That's still not more than 9. 3 doesn't work because 3 plus 6, that's not more than 9. So I have to start at 4. 4 plus 6, that would be 10. So that's more than 9. And that's as far as it goes because, again, this is the biggest number you could get for dice. Then let's try out 5. There's 5 plus 5, that equals to 10. 5 plus 6, that also equals to 11. That's more than 9. That's as far as it goes for the 5s. Let's see for 6. 6 plus 4, that works. We get 10. 6 plus 5, that would give us 11. 6 plus 6 equals to 12. And that would be my limit because, again, the first die, the biggest it could go to is 6 as well. So in total, we have 1, 2, 3, 4, 5, 6 different outcomes. 6 outcomes in total. And that would be 6 out of 36 again. And they already told us in the beginning that there were 36 possible outcomes. So it's 6 over 36. Okay, so again, this was not our original statement that we're trying, or probability that we're trying to find. We're trying to find the opposite of that. So again, I'm going to take the 1 and subtract it to my 6 over 36 to find out my actual probability. So from here, again, make this into a fraction. We get 36 over 36 minus 6 over 36. That equals to 30 over 36. Simplify it by 6. We get 5 over 6, which could also be, the probability would also be 0.833. And so that would be my final answer. Cool. So those are the three options for finding the probability that we're going to be looking at today. Hopefully this helped. Good luck.